Hello everyone. So let's try to solve this question. The question says find the number of integral solutions x and y, basically the pairs of x and y, for which above equation exists and the value of x and y are strictly natural numbers. Okay, so this is a kind of a Diophantine kind of a question wherein the value of x or different possible combinations of x and y are asked in a given set of domain. Okay, if you look at the entire question and if you look at the equation, you see that there are two unknowns, and it's very difficult to get any kind of an answer if you have just one equation to solve two unknowns. So you might need to use a little bit more of your brain to kind of solve this kind of questions. Um, let's see what kind of similarities we can draw by looking at both sides of the equation. Okay, so I will just rewrite the equation. It says x cube plus y cube equals 468 raised to the power 4. Okay, so let's see how we can kind of break this value. Okay, the moment I see there's something cube, I'll try to create a similar kind of a structure on the right hand side and then use the law of symmetry to sort of put a kind of a equivalent resemblance between both sides of the equation. Okay, so I would like to see how can I use the term 468. So we'll start checking different cube combinations which falls under this numbers. Okay, let's say we have 4 cube, we have 5 cube, we have 6 cube, 7 cube, 8 cube. So 4 cube is 64, 5 cube is 125, 6 cube, if my memory serves, is 216, 7 cube is 343, and 8 cube is you can say 64 there, and then 3 512, right? So we see different combinations here. None of them sort of falls under 468, but here if you notice, if you add 125 and 343, you get the value 468. So can we write 468 as 125 plus 343, or in another words 5 cube plus 7 cube? Okay, let's try to apply this in this equation. So x cube plus y cube equals, we will break this into two parts, into 468. Okay, 468 can be then further written like this. We then use our distributive property, cube into 5 cube plus 468 cube into 7 cube, and all of a sudden you see that you have achieved a symmetry that we were looking for. Okay, so if you see the overall value, this comes out to be 44, 4 here, 3, 23, right? Plus, if you see here, this comes out to be, so which is equal to, like, again you can see that this is symmetry already. So I'm just trying to put a number to it so that you know what the final value comes out to be, and this is equivalent to say 6, 5, 7, right? You can say here 6, 5, 4 here, 332, right? So as you can see that by law of symmetry, you can actually consider this to be two kinds of pairs. You can say that could be x could be 2340 and y could be 3276, or x could be 3276, y could be 3276, and x could be 2340. So these are the two pair combinations that we can get from this answer and hence the solution. Thank you for watching.